Okay guys, so logarithm functions and exponential functions. Suppose I got y equals ln x, and the derivative of that, the general result is, okay, 1 over x. Okay, so it's something to remember there. You've just got to remember that result. That's the general result. Just like you remember, you know, y equals sine x, dy dx is cos x. It's the same here. Y equals ln x, dy by dx is 1 over x. And then with the e to the x, okay, that's simple because dy dx is the same. It's the same function. Okay, so it just stays as e to the x. You get then functions of functions. So suppose I got ln of, say, x squared plus 1, okay. Well, when you differentiate that then, so we call that y equals, so when you differentiate that, you have dy dx equals, so this is function of a function, isn't it? Because this is ln of x squared plus 1. So the outside function is ln, the inside function is x squared plus 1. So ln becomes 1 over, okay, 1 over x, isn't it? But here, you know, we haven't just got x, haven't we, like we had up here. We've got this, so it'd be 1 over x squared plus 1. But then with the chain rule, then you times it by the derivative in here, which is 2x. So you end up having 2x over x squared plus 1. Alright? And you could get all sorts of functions in there. You could get, like, for instance, y equals ln of, say, cos x. Okay? You can have that going on. So then dy dx, well, you differentiate ln, so it'd be 1 over, in this case, cos x, and then you times it then by the derivative of this. Okay, the derivative of this, yeah? The inside function, and cos x becomes minus sine x. So when you differentiate cos x, you get minus sine x. So you get minus sine x on the top, cos x on the bottom. And that actually could simplify, can't it? Because sine over cos is tan, isn't it? So that'll be minus tan x. Okay? Now going back to the e situation, right, where e stays the same. Okay, it makes it nice, isn't it, when e stays the same. So again, now you could have function of a function. So suppose I have that e of 2x. So you differentiate the e, okay, first, the outside function, which is e, and that stays the same. Okay, and you times it by the derivative then of the inside, which is, you know, differentiate 2x, you get 2. So you get e to the 2x times 2. So that'd be e to the 2x. Okay, simple as that. You've got to be careful, because sometimes you get something like this which looks a bit strange. So you could have e to the, say, x plus pi squared, right? Now, let's look at this here. Differentiate this. Okay, differentiate e stays the same, so e to the x plus pi squared. Times it then by the derivative. Now, when you differentiate this, of the inside function, well, differentiate x, you get 1. Differentiate pi squared, you get 0, because pi squared is a constant, isn't it? So don't make the mistake of thinking it becomes 2 pi. It doesn't, it's a constant. So you times it by 1, so it stays the same, okay? Stays the same, nice and easy. You know, another example, you could have y equals e to the, say, x squared. So again, dy dx stays the same, okay? Differentiate the outside function, stays the same, times it then by the derivative here, x squared becomes 2x. So you get that, 2x e to the x squared, okay?